Okay, so looking at this triangle, if we wish to find the size of the angle here, how big will the angle be?
90 minus
90 minus theta. So this is 90 minus theta. What will be the length of this base?
1.
No? Cosine theta. So if you put the adjacent over hypotenuse is equal to the cosine of theta, and then you multiply the hypotenuse over to the other side, it simplifies. So your formula is that the cosine of theta equals adjacent over hypotenuse, which is the adjacent that we're after, that's 1. So the adjacent is equal to cosine of theta. What is the height of the triangle, therefore, going to be? You didn't work it out previously, use this strategy and work it out.
1 squared minus cosine squared.
Let's not go the hard way. That is the Pythagorean identity. We'll come back to that later. It's a good one. Go a little bit simpler. Sine theta. So this is the unit triangle. It's very useful. We can see that if we have a hypotenuse of 1 unit length, then you have these nice formulas for the sides of the triangles, sine theta and cosine theta. What's also special about this triangle is that those two sides are at right angles to each other, so we can stick it into the coordinate plane using, this would be the x value, and this would be the y value. So if we stick this into the coordinate plane now, we get a line like this one in the coordinate plane, and this line is 1 unit length. We put the triangle in here, we get this triangle, looks like this, with our right angle there. So the length of this side is the cosine of theta, and the length of this side is sine theta. What's the coordinates of this point on the circle? Cosine of theta, sine theta. So the coordinates here is cos theta, sine theta. And this is what we call the unit circle. So any angle can be described by the movement of this line AB here, rotated anti-clockwise around in the circle. So the angle 0 to 90, we will be moving that line up to this particular point. And we would always be getting cos theta, sine theta as the coordinates of this point on the circumference. All of the points created by triangles like this one will form a perfect circle because you have a set radius of 1 all the way around. So, some couple of understanding questions. What's the coordinates of this point here? Let me take it. Jonathan.
Yeah, 1, 0.
1, 0. What's going to be the coordinates of this point here? Let's see some new hands.
0, comma cos theta.
Well, it would be if theta was 90. So 0, comma cos 90 is true. Can you simplify that using your exact value table? No, sorry, 0, comma sine 90.
1.
This is 0, comma 1. What's the coordinates of this point here? Now you had a question or two. Let me take that.
Negative 1, 0.
Negative 1, 0.
So how do you have the coordinates?
Because we have a circle with radius 1. So here, this is 1 long. So if it's lying there perfectly, then the x value is 1 and the y value is 0. If it's lying here perfectly, the x value is 0 and the y value is 1. Here, because it's in the coordinate plane now, we describe a movement in this direction with a negative number. So in the coordinate plane, movements in that direction and up are positive. Movements down and in this direction are negative. Yeah, please. The last one, yes.
0, -2.
So this one down here is going to be 0, -1, our basic introduction to it. So to the unit circle. So we can find values using this diagram. We can make proofs with it. The most important part is the fact that the coordinates here is cos theta sine theta, and it's a right angle triangle with 1 unit length. So we're going to move this around all over the place. It lets us find a sine and cosine value that don't exist in a right angle triangle. So let's have a look at the first one. We want to find out what is the sine of 150. What is the sine of 150? So as we rotate, so we start off with this is what we call our terminal side. What we call our terminal side. We rotate it anti-clockwise. So if we rotate it anti-clockwise up to 90 degrees, it will lie here. So where should the terminal side lie? At 150 degrees. Let me just pause a minute. Where will the terminal side lie for 150? Which quadrant? Which quadrant is it in? No. Sorry, do we know which one's in which quadrant?
No.
Okay. So 1, 2, 3, 4. These are what we call the quadrants. And usually, I don't know, it's a bit geeky. Yeah, these are the quadrants. So in quadrant 2. So it's the terminal side. Let me just move that.
Terminal sides are constant, right?
Yes. So
Why is it in quadrant 2?
Because it goes counterclockwise.
It starts there.
Up. 180 will be there, so it's like somewhere in the middle.
So we rotate it around to here. So it's going to be around about there. What is the coordinates of point P? What is the coordinates of point P?
I don't understand the circle with the line, the symbol.
Which symbol?
The circle with the line.
Either.
Yeah, I don't know what that is.
It's like an X placeholder.
So you know how we use X for an unknown, and then we use Y for a certain unknown, and we use Z as the next unknown. We have a preference for certain parts of the alphabet to use for certain things. So variables and unknowns are X, Y, Z. Functions, we start at F, and then we use F, G, H. Constants, we use A, B, C, D. We start with that part, yeah. Constants, which are integer values, we use N, M. Angles, we use Greek letters, we use theta, alpha, beta, gamma, and so on. So theta is the one that we like to use most for an unknown angle. It helps us when you're reading something. Okay, you see this theta, you know it's related to being an angle. Oh, helps.
And delta means change. Is B -1 up?
I'm not going to simplify it yet. I'm going to put it into as trigonometric values.
I think minus sine, comma cosine.
It's actually going to be, so our rotation here, how many degrees have we rotated?
150.
This is 150. So this is cosine of 150, sine of 150. That's the coordinates of B. Cos 150, sine 150.
But that's.
We can simplify, but we haven't learned how to do it yet, because we only know the angles between 0 and 90. Now we're going to learn how to do other angles. So we need to find out what those values are. And we can find out what the values are by our understanding of angles in the period from 0 to 90. So if we rotate this way, how many degrees would that be? In the coordinate plane, rotations for, like length. If we move that way, it's positive. If we move this way, it's negative. with angles. If we rotate counterclockwise, it's positive. If we rotate clockwise, it's negative. So this is negative 30 degrees. But from a geometrical perspective, it's 30 degrees. So in the coordinate plane, it's a negative rotation. But we can also see it just as a triangle with at one angle equal to 30 degrees. So if we see it, this blue triangle I've just drawn as being one of these unit triangles, where this angle theta is equal to 30 degrees, like this, we can see it like that. So if this angle is 30 degrees, what is the height here?
Which is 3 square root of 3.
We could see it as sine of 30. And what is the sine of 30?
1/2.
So this length here is a half. What is the length? Let me just remove some bits and pieces. I want these out of the way now. What is this length here?
Square root of 3 over 2.
This is root 3 over 2, but in the coordinate plane, would it be positive or negative? Negative. So the triangle would be root 3 over 2, but in the coordinate plane, that's going to be minus root 3 over 2 to show that we're moving along the x-axis in the backwards direction. So now, tell me what the coordinates of this point are.
Negative root 3 over 2, comma.
Negative root 3 over 2, comma, 1 over 2. If we were to have this one triangle over here, where this is 30 degrees, what are the coordinates of this point Q? So we start to see the symmetry involved in this. There's a lot of symmetry. There's a lot of moving these triangles around and just placing them in different places to find our angles that we're after. No, because this time we're moving in a positive direction. So the line is going this way, whereas here the line is going backwards.
I mean for the other one.
No, because the line is always going up. So the half is this direction here. These two lie on the line, y is equal to a half in the coordinate plane. Both of these points lie on the line, y is equal to a half in the coordinate plane. So what we see in this one is that the sine of 150 is equal to the sine of 30 is equal to a half.
How can we say that the sine of 30 is equal to the sine of 30?
How can we say the sine of 30 is equal to
How do we prove that?
That the sine of 30 is what?
Is equal to the sine of 150.
Because these two triangles are identical. They're congruent. So triangle OQA and OPB are congruent triangles.
Yeah, but how did we prove it in the first place that the sine of 150 is equal to the sine of 30?
We don't have to. If we start by proving that those are congruent triangles, and then you simply place them in the coordinate plane, we can see what the spaces are going to be. Okay, so it comes from the exact value table here, which we proved earlier last lesson.
Why did we write cosine 150 sine 150 as a point?
Because we can see from this diagram that the sine of 150 and the sine of 30 are going to be equal because they have the same y value when we found out these two values. We're going to do some proofs of formulas like this one later, but we're working numerically at the moment while the slightly glazed looks on your faces subside slowly. I can tell by the looks on your faces the pace I should go. You can see I'm going slower, can't you? As you sort of, your brain grasps this.
So complementary or supplementary angles will be the same. Like for example, if you had like sine 100 and sine 80, would they also be the same, or is it just for like this one?
180?
Like
That's supplementary.
Like here 150 and 30 they add up to like 180.
Right. Yeah. We'll prove it later. So what you're asking is the sine of 180 minus theta is identical to the sine of theta.
What's the 3 part? Why can't you just write equals?
Because it's true for all theta, not just some.
Oh.
It's an identity.
I think I just missed this part, but how do we figure out the height was 1/2 of it?
Symmetry. So we have this right angle triangle here, and we know the angle is a 30, so we know that this is a half, and we know that this length is √3/2. If we take that and we just flip it and place it here, we create a congruent triangle. So its sides are going to have the same lengths, but in the coordinate plane, the base is going to be negative because you're moving backwards.
Can it also be, instead of just, can it be also cosine the 180 minus theta?
No.
Only sine?
You can see there in the, you can start to see it here.
Also, it's a minus.
What do you think it's going to be? Give me the formula.
Cosine 180 minus theta is identical to negative cosine theta.
Yeah. These little identities we'll prove later and we'll look at later. At the moment, I'm just working a bit more numerically. All right, let's try. I'll just copy this. Duplicate. Okay, let's try number 2. We've got the cosine of minus 60 degrees. So, which quadrant will the terminal side for this one lie? Which quadrant will the terminal side for this one lie? No.
4.
4. It's going to lie in the 4th quadrant. It's going to be down here. And here is our triangle. Here is the angle 60 degrees. And we've got a negative rotation there, so minus 60 in the coordinate plane, but 60 in the triangle. So the angle in the triangle geometrically is 60. In the coordinate plane, we express that negative 60. That triangle is congruent to this triangle, where this angle is 60. What are the coordinates of point P?
100.
Sine 60.
Sorry?
Why is it on top of that one and not like on the side that last?
Because the angle's bigger. I could have shown it looking the same. So the last time I showed with an angle of about 30. This time I'm showing with an angle of 60. When I'm doing diagrams in the coordinate plane, I always tend to use a triangle that looks like one angle is 30. Never 45, which then you get stuck a little bit. It's good to have a triangle that isn't isosceles when you're looking at your diagram, so you see that this value is smaller than this value in this case. Okay, so
For cosine, would you move clockwise, or is it, so why did they go down? Is it because it's negative?
it's because the angle is negative. So you would also find the sine of minus 60 with this triangle down here in the 4th quadrant. So minus 60, the terminal angle, is in the 4th quadrant.
Is it cosine 60, sine 60?
So this one up here, we can write it in 2 ways. It's cos 60 degrees, sine 60 degrees. What about point Q? What is the coordinates of point Q in terms of 60 degrees? In terms of 60, not negative 60. Yeah, let me put that in here then. You're looking here. Yeah. What about here in terms of cosine of 60, sine of 60? What would it be?
Cosine of 60 and negative sine of 60.
Exactly. So we can express this as the cos of 60 and minus the sine of 60. We're pulling this up from the symmetry of the situation and the fact that those two triangles are congruent. And instead of moving vertically, you're always moving in this direction for both the same side. They share that side. So this one goes up, this one goes down. So it's just simply negative version of that one. So the coordinates of Q will be what? What are the coordinates of Q? Let me have somebody else. You don't know.
Would it be √3/2 comma negative a half?
Nope.
And then
2.
Sorry, can you wake the guy up next to you? You really have got to stop gaming through the night and start sleeping better. This is the 2nd time that you've been falling asleep in class. Let me take somebody fresh. Who would like to have a go at this? What's the y coordinate at this point going to be?
Negative 1/2.
Yeah, minus 1/2.
Wouldn't that just be a negative half?
It is.
That's the answer, but going Did I say it wrong?
You said half.
Did I?
You said a positive value. Okay. Where are we up to now? Oops.
Wait, isn't it cosine
Isn't it?
of 60 and half?
Yes.
Yeah.
Oh,
Cosine of
yeah, are we?
sine of 60 is
Yeah,
over 2.
all right. Somebody gave me these ones backwards. They sounded sensible at the time. You can see it by the lens, the shorter one, can't you? Yeah. Visually, we should have caught that. Okay. Moving on. Which quadrant's 210 going to be in?
210 is.
Let me take some of that out. The third quadrant. So the terminal side is going to be about there, like this. This is the rotation, 210 degrees. This triangle is congruent with a triangle in the first quadrant. This triangle is congruent with a triangle in the first quadrant. So that triangle would look similar as well, like this. What is the angle of rotation of this triangle? What is the angle of rotation of this triangle? Somebody over the back there. You want to give me an answer? 30 degrees. This one will be 30 degrees. So here we got 30 degrees. So what are the coordinates of point P? At the back,
Cos of 30 and sine.
cos 30, sine 30. Let's go straight to the numerical values now.
Root 3 over 2 and 1 9.
Root 3 over 2 and 1 over 2. What are the coordinates then of point Q? What are the coordinates?
Negative 3
It's not the inverse.
Okay, then negative 3 over
Negative.
2 and negative 1.
Yeah, they're both negative here, aren't they? So it's negative root 3 over 2 and negative 1 over 2. Ants. Sorry, can I have quiet a second there?
How would you know
Just by the fact that we're the direction in which we're moving all the time. So we're moving backwards and we're moving down. So in this quadrant, both sine and cosine are positive. Here, sine is positive, cosine is negative. Here, they're both negative. Here, sine is negative, cosine is positive.
How did you know that the angle inside was 30 and not?
Because we know that this point here is at 180 degrees.
Yeah.
And how far past 180 have we gone?
20, 10 minus 90. So then that's 12.
what did you say about the quadrants again? I missed it.
I will come back to that when we do tan as well. But it's just which one's positive? Which x and y value is positive in which quadrant?
Okay.
That's what we're talking about. All right, 270. Can you do this one for yourself?
Can we do it on sheet?
Sorry?
Can we do it on
Not yet. Oh, let's give some instruction on that one. So what was the sign of 210? We didn't answer the question.
Okay, with the 9.
negative 3 over 2?
Which one of the values do we want?
Negative 1 over 2.
Yeah.
So we did the cosine 270 now?
Yes.
Goes 1, 2, this goes 3. And 270 is that 9 days. 270.
Trying to draw a triangle with a 90-degree angle. It's funny. It's not that.
So I know I live, I do something wrong. So it's 270 like this. So it's 270 like this.
And then else with the right
How would you? A square.
No, try to throw a square destroy to the other side. What's the other side? Where?
Go on my key.
That's 270. Okay. 270 degrees. Where does the terminal side end? Where does the terminal side end?
It ends on the no, it starts on the so it ends on the fourth. It's like one.
No.
It ends on the negative part of the y.
It ends on the negative part of the y-axis. So the terminal side in this case is lying here. What's the coordinates of this point here? What's the coordinates of this point here? Nope. One of your answers was right, one of the numbers was wrong. This is 0, negative 1.
It's a unit circle, so we know which radius we want.
Yeah. So what is the cosine of 270 degrees? 0. The x coordinate. The x coordinate. Okay. It's time to fill it with some water. Have a go. Have a go at these questions. Have a go at these questions for yourself. That's how we make it. Start with a triangle. So you can try.
Because you're just looking at it. Oh, right.
Is this on the test? No.
Don't answer that question just call me ever again. Don't ask what the test is. This is what the test is. You go places in the wrong place. You should be on learning and enjoying it. It's a lot of it when we end the test. You're missing the test. Okay, you need to see where you need to see where the terminal side lies.
So how do we get to where the terminal lies?
By rotating it from the line between the origin and the circle, that's the x-axis. prime versus so always starts off going from 0 to 1,0. That's its start. And then you just rotate around. 70 is the minus 1. So you do 1, 2, 3. That's hypotenuse in the diagram there. That diagram there. Because the hypotenuse is drawing a circle. That terminal side is the hypotenuse always, and it draws a circle.
The terminal side of the hypotenuse. The image was always one.
That's what you did. Yeah. No problem. The answers are easy.
Certain number 6. Cosine of this angle is equal to cosine
No, always rotating. That way.
This one right here.
This is sine of
Where are you talking about? I will be when I explain this. One more minute.
Always the Y here,
Always the Y.
so for the last one, always the X.
This diagram is what you get in the formula sheet.
We're getting it.
I've never used it.
That's how far I got.
You get that on the formula sheet. I've never used it. So, at the end of the unit, this stuff is easy. Today it's not. It's new. It's still drafting. And it isn't real conceptual thing to grasp. Different people are good at this. This is for visual, but it's really, really good. Some guys are very good at mechanics. Analytic geometry. Well, you have these coordinates, and you can use these values here. Yep. 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 You've got the diagram. What's the cosine side?
You're so stupid.
All right, let's stop there. Let's stop there. That's a good thing, at least there's one to solve. Okay, guys. Okay. let's look at the answers. Let's look at the answers. So, with this whole concept, we start with a line that begins here, and this is 0 degrees. We define our angles by rotating that line however many degrees we are told to rotate it. Anti-clockwise rotations are positive. Clockwise rotations are negative. It always starts there. So if we rotate it round to this point here, and then we define the angle, the rotation of x in this direction. So the sine of x is given by, so we have our definition for the formula of the unit circle, which is this. The x coordinate is the cosine of whatever angle we've just used. The sine is the y coordinate, whichever angle we've just used. So for this first question, the answer to sine x, we can read from the diagram, is 0.6. That's it. So now we have to use a little bit of symmetry to rotate it to different places. So if we rotate that red line all the way around to here, we've given a rotation of 180 degrees. So if we rotate it to this point, we've rotated 180 degrees. So that's the cosine of 180. Now if we then rotate backwards by x, we will draw a triangle. We'll have a terminal side here, like this, because this is minus x. We've gone backwards by negative x. What will the coordinates where the terminal side meets the circumference of the circle in this case be?
0.8, no, sorry, negative 0.8.
This is negative 0.8, 0.6, like this. So we can just read off the answer now. What is the cosine of 180 minus x? This is negative 0.8.
I thought it was the y.
Cosine is always the x value. It's given in the formula. So if we go back to this formula, cosine is always the x value. Sine is always the y value. Always. Never messes around with it. Complete. So where do we need to put the terminal side now for this one? We need it in the third quadrant, don't we? We rotate round to here, which is 180, and then we rotate a little bit more down here to a plus x. So this is plus x. What will be the coordinates of this point here? What will be the coordinates of this point here?
Negative 0.8, negative 0.6.
Yes. So this point here is going to be minus 0.8, minus 0.6. So the tan of 180 plus theta is going to be the same as the sine of 180 plus x over the cosine of 180 plus x. So we can read our values off, and that would give us minus 0. Which one's the sine value?
Sine of 0.6.
Over negative 0.8. Simplifying that, we get 6 over 8, we get 3 over 4.
I don't think you can
Like the way you always think we check it. Okay, we ready?
Yeah.
So that's the easy bit.
Easy.
When it's new to you, it's overwhelmingly difficult. But 3 lessons into this, what we just did there is the easy bit. Right now, it's not. It's all about a matter of perspective. Questions you've never seen before are hard. Questions you practice 20 times, it becomes easy.
I have a lot of study to do when I get home.
I've taped it. So we're looking at the reciprocal trig functions. The reciprocal trig functions are the cosecant function, the secant function, and the cotangent function. These are 1 over the major trig functions. So cosecant x is 1 over sine x. Secant of x is 1 over cos x. Cotangent x is 1 over tan x. Not a huge fan myself of these trig functions. Whenever I get a problem with those in, I replace it immediately with the proper one. I don't know. I'm not a big fan of them. But they're on the syllabus, and you'll be tested on them a little bit. So let's have a look at a question or two.
Can you go back for a second?
How far?
This one. Back to the slide.
Slide back.
Question about this one. So I did minus x. This
Yeah.
one is 180.
Yeah.
And you went back
X.
So why did you like this triangle and not this big one? Because when the
Yeah, because the angle is here. There's the angle of the x. There's a triangle like here congruent to that triangle. So sometimes I'm working in rotation, sometimes I'm working in the triangle.
Every year they make the course harder.
No. You're not. I'm hoping to get you prepared for it.
My brother is not prepared. He did this class, but he still gets this bad.
Yeah.
My sister is a bit lost. She got A+ in every single test from the grade advanced, and she's still kind
Yeah. The level isn't quite right before. It's a little better now. Let's have a look here. The terminal side of an angle theta in standard position intersects the unit circle at these coordinates. What is the sine of theta? And you guys who've got it, I'm not taking you. You guys who've got it, put your hands back down. Let's have some new people who've not answered the question. This one's super easy. This one's super easy. One. Yep. 65 over 97.
And why did they say terminal side?
Because I've been using the vocabulary that this blue line there, the green line there, and that purple one, that's the terminal side after the rotation. So it starts in its initial position and it rotates to its terminal position. I'm using this vocabulary for you guys because these are on the SAT scores a lot. They love questions like this on the SAT, and I wanted to make sure you knew what the word terminal meant. I came across this about 10 years ago, and a kid was taking the American SAT. So what does this mean? I haven't got a clue. I'm guessing it means that. And I was right, but I had never heard the word before. Quite a, but yeah, anyway. All right, let's try 9. Discuss it with the person next to you a little bit. Okay, just be careful, because we have, in the trig functions, we have sine and cosine. But these go the other way, secant and cosecant. So it's very often, when you're first getting to use these ones, you connect secant and sine, cosecant and cosine, because they have the co in it. But it's the opposite way around. So, the cosecant of theta, at the back. 37 over 35.
Okay, so it's asking for CSC, which is 1 over sine of x. We know that the sine of x is the y value, so we have 1 over 35 over 37, and 1 divided by 35 over 37 equals 37 over 35.
With fractions over fractions,
Same change there.
with fractions over fractions, you can move the denominator and multiply it on the other side. So if there's a fraction on the top, you can take the denominator and multiply it at the bottom. There's a fraction in the bottom, you take the denominator and multiply it in the top. Otherwise, you just look at turning the fraction upside down like this. Have I got these ones? One more minute.
The first one I got 6 times square root of y over
Okay, let's stop there. Let's stop there. Remember that the cotan of theta is equal to 1 over tan theta. And that means that we need cos theta over sine theta. Tan theta is sine theta over cos theta. So cotan theta is cos theta over sine theta. So then we can take these values. The cosine is this one here, minus root 5 over 3, all over 2 over 3. Now,
Isn't it sine over cosine?
Yeah.
Tan is sine over cosine.
Oh, but because it's a cos. It's a cos, so you flip it, yeah. What? You flip it's okay, take this 1 over tan, which means you can flip them. So instead of sine, you can cosine.
You have to
You can do it this or later. I did it later.
So 1 divided by a fraction is the fraction's reciprocal.
because x is the reciprocal function. Okay, have we caught up now, guys? Excellent. So we can actually go one step further because these are going to cancel straight off. So our answer is equal to minus root 5 over 2.
That's the answer.
There. Like when we're using the exact value table, if you notice that the denominators are the same, you can ignore them. So if you want sine over cos or cos over sine, you can just go straight to it by looking at the numerators. Right, let's do this one on the board. It's a good question.
So like, what's the point of using like cosecant, secant, and
I haven't figured out that yet. Some formulas look simpler. So the derivative of tan x is secant squared x. I just write 1 over cos squared x. We'll get there next year. The terminal side of the angle has these positions. What is the cosecant of theta? So we want the cosecant of theta, which is 1 over the, which one? Sine of theta. So which one of these is the sine?
Y.
The y. So the answer is minus 9 over root 39. Now, we can't enter it like that. We need rationalized form. So that is going to give us minus 9 root 39 over 39.
Why did I have to be rationalized?
Because the question says so.
What's the benefit?
The benefit with fractions of having that rationalized form is it's easier to compare. Are these two the same fractions? So it's like a standard simplified form. So when you look at a bunch of numbers, you're like, these ones are the same. If you've done that, otherwise you might not notice it. Also, it's better to have the denominator rationalized because if you're doing fractional arithmetic with it, it's easy.
So you didn't simplify it. Negative 3 over 13. Like,
No, but it's not.
it's not into
Yeah, he's right.
It's divisible by 3, yeah?
Yeah.
So it's 3 over 13, right?
Wait, I have a question. Why did you put root 39 over 39? Don't just do that and then
So you multiply both sides by root 39. And root 39 is only equals 39.
Okay, let's move on. I'll just draw the numbers a bit bigger. It's minus 0.97 and 0.26.
Yeah, but I don't get it.
It's not, it's 19.
I started with halfway through this course, and now we just sit there, we just test the hard problems. So he learns the easy stuff in class.
And then why do we come to school to learn it?
We only have so many hours in this course. So we have the same amount of hours to get through. And if you imagine the amount of content there, those compared to how much we learn for I3 regular.
I'm actually ready.
The special So I Okay, let's look at some answers here. Let's look at, we need time for the hard questions still. The first one.
It's negative 0.97.
Nope. Anas.
So the it's normally it would be minus, but negative and then negative. Cosine has to be the.
So when we've got these values here, this is the cosine of what value?
Negative.
No?
195.
No?
100.
No?
165?
165.
How?
180 minus 15 equals 165.
Because we're rotating backwards from 180, this is the angle 165. We always rotate from the principal position round to the terminal position. And if we've got a triangle there with a 15, it means we've rotated backwards from 180 to 180 minus 15 is 165. So that's that one. So this one will be congruent to this triangle, but it will be in the first quadrant, so it will be positive. What about here? Which quadrant is 195? It's this one down here, isn't it? Where we rotate positive 15 down here. So the values are the same, they're both negative. So the coordinates at this point is 0.97, comma, minus 0.26. So what is the secant of 195? What is the secant of 195? Let's see some new hands. Here we haven't spoken today. Minus 1 over 0.97. Is this number bigger or smaller than 1?
It's bigger.
Bigger.
Bigger. Bigger. This number is bigger than 1. Well, would it be negative technically? Sorry, I'm not thinking straight. Would it be negative? It's smaller than negative 1. But I was thinking of the absolute value. Alright, 14, cosine of 105. Now this one's trickier. This one's trickier. We haven't done one of these yet.
No, but it's minus 197. It's the inverse of the inverse. But it's a negative one.
Where is 105? This is 105. We haven't done one of these yet. Watch this one carefully. So the positive y-axis is 90, and I rotate 15 past that in this direction. So what are the coordinates here of point P? Look at the symmetry, look at the triangles, look at which side is short, which side is long. Look at which side is short, which side is long. Is it the y value, the x value? Are we going positive direction, negative direction? Think it through from the symmetry of the situation. Another one.
Minus 0.26, 0.97.
Yeah.
So,
Reflection.
minus 0.26, comma, 0.97. Look at the triangle. So this length here is 0.26. This distance here is symmetrical with that one, congruent with that one. It's moving in a negative direction. That's the x coordinate. This y coordinate becomes this x coordinate, and vice versa. And this moves in a negative direction, not a positive. Likewise for the other length. This one comes in that direction, like that, minus 0.97. This one moves up in this direction, it's 0.97. That long side and short side on the triangle, as you move it around, is why I say always draw your triangle so it looks like one angle is 30 degrees. Because if you do that when your angles look like they're 45 degrees, you don't see it. So when you're making a representation, you don't have to be completely accurate. It's always good to have a triangle that looks like this. So you see a short side and a long side, and you can catch things like this. That will help you. So what did we get as the answer here? This was going to be the cosine, so minus 0.26. All right, last problem, it's the hard one. Have a go at this one. These ones. Duplicate. So I don't have to erase it in the diagram.
Places in the opposite of B.
That we haven't seen before, right? But using the concept that we learned, we should be able to do it.
So like now, this is the perfect. What we're doing now is we're practicing problem solving for examples. We're doing questions and everything is useful.
But it's so different.
Yeah.
It's not the same at all.
That's what problem solving is. So what we're looking at here is very simple. Everything.
We don't get to sign of the nature. So this is almost big. We get to sign.
Me too. I didn't have any tutors. I got so if I was in a lecture, I wouldn't be helpful. I noticed I would just walk.
So if you just find this side, we can this side.
What's I know. This is doing that, and that's your. I would like that going up.
You gotta find this side. This is over at this side. And this is this side.
I remember everything you said.
Yes, why is that? Why is that? One over one. For example,
Am I supposed to find the video? Okay, so let's try that. 5 plus 8. That would be 5 to just 1 minus negative 4.
So then 2i over 5.
All right, let's stop there. Let's stop there. Let's stop there. We have a right-angled triangle here. We have a right-angled triangle. What is the length of the hypotenuse?
1.
What is the length of this side?
5.
What is the length of this side? So, don't forget, if you're going to use Pythagoras' theorem or any formula, say what formula you're using. So, Pythagoras gives, and we need 1 squared equals a squared plus root 5 over 3 squared.
So it's 5 over 9.
So we get 1 equals a squared plus 5 over 9. So 9 minus 5 over 9 equals a squared. So 4 over 9 is a squared. A is equal to plus minus 2 over 3. Yeah, but we start with plus minus because we've got an equation given by Pythagoras, which we've set up and we solve to its conclusion. At this point, we have to interpret which of these two is the correct answer. So as point lies in quadrant 2, A is equal to minus 2 over 3. So with a problem like this one, you have to, if you're going to throw away a solution, you have to reason why. You have to find both the solutions or all of the solutions. They have that reason why you're throwing certain ones away. Depending on how the problem was worded, it could have been worded differently, and it could have had 2 solutions to the problem. It could have had 2 solutions. Okay? So, to finish off, I've given you out a unit circle, not worksheet, a unit circle. So, here, see where there is the degree symbol. On that one, fill in what the angle is, terminal angle in degrees. The next one up, leave that one blank. We'll put that one in later when we see radians. So next to the degree, there's 2. So you only fill in the one with the degree symbol and the coordinates. So fill in the coordinates, fill in the one with the degree, and you can do that before we leave today. There's a homework sheet on the Google Classroom to practice this, and there is a small IXL to warm you up. I will pause the video now. I'll stop the video.